So in this video, we're going to talk about something called an oxidation-reduction reaction. The short version for this, or the shortened term for oxidation reduction, is redox. So reduction oxidation. And a redox reaction occurs when there's a transfer of electrons from one atom to another as part of the chemical reaction. So when electrons are transferred from one atom to another. So there's two parts. There's the oxidation part and there's the reduction part. So oxidation occurs when an electron is lost. So when we're looking at a chemical reaction, and we're going to use sodium as our example, we're starting with sodium metal and forming sodium ion plus a separate electron. So since the electron shows up on our product side, that means that it's lost from the sodium. So oxidation is a loss of electrons. And then reduction is the opposite. So we can use our chlorine example. So we have chlorine atoms, so it's diatomic, so it's Cl2. And if we add 2 electrons, we get 2 chloride ions, each with a -1 charge. So reduction is gaining electrons. And we know that by this reaction, it's gaining electrons because electrons are being added on our reactant side, not showing up on our product side. So if electrons show up on your products, it's a loss of electrons or oxidation. If your electrons show up in your reactants, it's gaining electrons or reduction. So there are 2 ways that we can remember this. The first way is by using the phrase, Leo the lion goes grr. Now, I know it sounds kind of silly, but trust me, it'll get stuck in your head. Leo the lion goes grr. Leo is loss of electrons is oxidation. And then grr is gain of electrons is reduction. So Leo, loss of electrons, oxidation. Grr, gain of electrons is reduction. So Leo the lion goes grr. Another way to remember it is with the phrase or word oil rig. So this is pretty similar. Oil is oxidation, is loss, and then rig is reduction, is gain. So either phrase, doesn't matter which one, but those are 2 easy ways to help you remember oxidation versus reduction. So let's look at 2 examples of how we actually apply this. So this is the type of problem that you would see as your practice. This is what we're going to ask you to do. So we're going to give you a reaction and we're going to ask you to identify the oxidation, what's called the half reaction. So what part of this is oxidation and then what part of this is reduction, and then write and balance that piece. So we know that oxidation is losing electrons and reduction is gaining electrons. So if I look at my reaction here, I have iron plus 2 going to iron. Now, in order to make that happen, we're going to have to add electrons. And if I'm adding electrons, what type of reaction is it? Well, reduction is gaining electrons, and so this is going to be my reduction reaction. So I have iron plus 2 going to elemental iron. And in order to do that, I need 2 electrons. So this is my reduction half reaction. Now, my other half is going to be my oxidation half reaction. So in order to go from a neutral to a positively charged ion, we know that we need to lose electrons. So I'm going to start with cobalt. and then it's going to turn into cobalt ion with a +2 charge. And then in order for it to have a +2 charge, I need to lose 2 electrons. So my oxidation half reaction is written and my reduction half reaction is written. And that's it. So you just have to keep in mind what happens to the charges when we gain and lose electrons, because that's what you're going to be looking at. Let's look at our second example. So our second example has 2 elemental things going to 2 ions. So we have potassium reacting with chlorine to produce potassium ion and chloride ion. So if I'm looking at my potassiums, going from neutral potassium to a positively charged potassium, in order to go from neutral to positive, I know that I'm going to be losing electrons. And in order to go from neutral to negatively charged, I know I'm going to be adding electrons. Now, oxidation is loss. So we have our oxidation half reaction is going to be our potassium going to our potassium ion. And then since I have 2 potassiums and 2 potassiums here, I need 2 electrons. And then reduction is gaining electrons. So I'm going to go from my neutral chlorine, and then I'm going to add 2 electrons to turn it into 2 chloride ions. So if you notice, my charges have to balance. So this side is neutral. 2 times a +1 gets me +2. 2 times -1 gets me a -2. +2 plus -2 gets me 0. So those are equal on both sides. Same over here. So this is neutral plus 2 negative charges, so that's -2. And over here we have 2 times a -1 gets me a -2. So they don't necessarily have to be neutral on both sides. They just have to be equal on both sides of our reaction arrow. So that's how we write oxidation and reduction half reactions.